Hey there, welcome to another lesson of this AWS Security Specialty Certification course. In this lesson, we are going to be covering one of the most popular and used services within AWS, which is Elastic Load Balancing. So an Elastic Load Balancer distributes the traffic automatically across multiple healthy EC2 instances or other services that are running on top of EC2, as we will see later on. It acts as a single point of contact to the clients, and it transparently increases the application availability by allowing the addition and removal of multiple EC2 instances when needed. When it comes to the main benefits, ELB is a distributed system that is fault tolerant, and it is designed to not be a single point of failure. And you can really notice that when you realize that AWS requires you to have at least 8 different IP addresses available in the subnet in which you want to deploy an ALB. ALBs abstract the complexity of managing, maintaining, and scaling load balancers, and are going to be acting as the first line of defense against attacks. They also can perform SSL termination and are integrated with autoscaling and other services like EC2, Lambda, Fargate, EKS, and ECS. Finally, I wanted to cover three key concepts around ELBs. First of all, we have the listeners, which are checking for the connection requests coming from your clients using the protocol and port that you have configured, and they are going to be forwarding the request to a target group. So a target group routes the request to one or more registered targets that can be EC2 instances, containers, Lambda functions, or IP addresses using the protocol and port number that you have configured. Finally, we have the health checks. So a health check is a way of asking a service on a particular server whether or not it is capable of performing work successfully. So if, for example, one of your EC2 instances is not working as expected, ELB is going to be flagging that instance as not healthy and will avoid sending traffic to that specific instance. Now, there are different types of load balancers we can use according to the use case we want to cover. First of all, we have the classic load balancer. So this is a legacy load balancer that is only to be used with existing applications running on top of EC2 Classic Network. So the usage of this type of load balancer is actually nowadays not recommended. Then we have the application load balancer. I would say this one is the most popular one, and that's the best choice when you want to support HTTP, HTTPS applications with advanced routing and visibility features. We also have network load balancers, and those are the best choice for ultra high performance and whenever you want to support TCP, UDP, and have a static IP address for your application. Finally, and this is a new type of load balancer, which is the gateway load balancer. And you should only choose this one when you need to manage a fleet of appliances that support a protocol that is quite new, which is called GNIB. So GNIB is an IP tunneling-based protocol that is supported by some devices. So if that's your case, you should stick to the gateway load balancer. Okay, so before we finish this lesson, I just wanted to provide a quick summary about the unique features that are related to each type of load balancer and also the ones that are shared across all of them. It is really important for you to remember this for the certification exam because it is highly likely that you are going to be receiving several questions around this topic. Let's start by the unique features associated to application load balancers. So we know application load balancers are layer 7 load balancers that support content-based routing, meaning that if your application is composed of several individual services, an application load balancer can route a request to a service based on the content of the request, such as the host field, the path URL, HTTP header or method, query string, or source IP address. You can also implement redirects or fixed responses. So you could, for example, use a redirect to upgrade a connection from HTTP in port 80 to HTTPS in port 443. ALBs are the only type of load balancers that support Lambda functions as the targets, and you can also implement mutual TLS with ALBs. So mutual TLS is a protocol for two-way authentication between clients and servers that use X509 certificate-based identities. So with this feature, the ALB will authenticate client thirds and perform revocation checks for certificate issued by both third-party certificate authorities or private certificate authority service in AWS. Finally, you can use the WAF, so the Web Application Firewall, to protect your applications exposed to application load balancers from the most common threats or web attacks. Let's have a look at the unique features now of the network load balancer. So in this case, if your application is requiring an static or an elastic IP, then you should go for network load balancers. Finally, we have the classic load balancers. So in this case, if you are using the legacy EC2 classic network, you need to use a classic load balancer. But as we were saying before, this type of load balancer is now legacy. And these load balancers support sticky sessions, but within the same EC2 instance. So we will talk about sticky sessions in a moment. Okay, if we have a look at the features that are shared between NLBs and classic load balancers, both are layer 4 load balancers and both support TCP and TLS. If we have a look at the features shared between ALBs and classic load balancers, we have that both are supporting HTTP and HTTPS, and we can configure idle timeouts. So for each request that a client makes through a load balancer, the load balancer is going to maintain two connections. So the front-end connection is between the client and the load balancer, while the back-end connection is between the load balancer and the target. So the load balancer has configured a timeout period that applies to its connection, and if no data has been sent or received by the time that the idle timeout period elapses, the load balancer closes the connection. If we have a look at the features shared by the ALBs and NLBs, first of all, we have SSL termination or SSL offloading. And in this case, both application load balancers and network load balancers supports client TLS or SSL termination. And this enables you to offload TLS termination tasks to the load balancer, therefore saving compute cycles in your web servers or in your audience in general. They both support sticky sessions, in this case for the same target. And a sticky session is a mechanism that is used to route requests from the same client to the same target. So the key to managing sticky sessions is determining how long your load balancer should consistently route the user request to the same target. So sticky sessions are enabled in this case at the target group level, as I was saying, unlike the CLBs, because in that case we enable it for a particular EC2 instance. They both also support WebSockets. So WebSockets are long-lived HTTP or HTTPS connections. They support multiple ports in the origins, and they also support SNI. So SNI stands for Server Name Indication, which is an extension to the TLS protocol, by which a client indicates the hostname to connect to at the start of the TLS handshake. So the load balancer can present multiple certificates through the same secure listener, which enables it to support multiple secure websites using a single secure listener. So let's finally look at the features that are shared across all of them. First of all, they all live within a PPC. They all support health checks. They are all integrated with CloudWatch service. They can all for sure implement logging. And finally, they all support both cross-zone load balancing and zone failover. So that's all for this lesson. Hope you like it and see you in the next one. Bye.